All right, we've got a stack of research here on fast radio bursts.
Oh, yeah.
And let me tell you, this stuff is wild.
It is.
We're talking about signals
Right.
so intense.
Mm.
They pack the energy of the sun for an entire day,
Wow.
but squeezed into a fraction of a second.
Yeah, it's unbelievable.
It's incredible.
It is.
And the fact that these signals, these FRBs,
Yeah.
come from billions of light years away
Billions.
only adds to the intrigue.
Exactly. It's mind-boggling.
So for this deep dive,
Right.
let's explore what we know about FRBs.
Sounds good.
How were they discovered?
Okay.
What makes them so unique? And perhaps most importantly,
Yeah.
what can they tell us about the vast universe we inhabit?
It's a big question.
It is a big question.
Yeah.
Now, the discovery of FRBs seems like something out of a scientific detective novel.
Uh-huh.
It involves poring over old data
Yeah.
and finding something completely unexpected.
Right.
Tell me more about that.
Well, back in 2007, a group of astronomers was sifting through archival data from the Parkes Radio Telescope in Australia.
Okay.
This data was from 2001, so it had been sitting there for years.
Wow.
They stumbled upon a curious signal, a brief, incredibly intense burst of radio waves
Wow.
that no one had noticed before.
Oh, wow.
This became known as FRB 010724,
Okay.
the first confirmed fast radio burst.
Wow. Talk about finding a needle in a haystack. But I imagine there was some initial skepticism.
Oh, absolutely.
How could they be sure this wasn't just a glitch in the data, some kind of equipment error?
Of course, scientists are inherently skeptical,
Right.
and rightly so.
Yeah.
But the characteristics of FRB 010724 were just too unique to ignore.
Okay.
It was incredibly short, lasting just a few milliseconds, yet it packed an extraordinary amount of energy.
Yeah.
And perhaps, most importantly,
Okay.
the way the signal was dispersed suggested it had traveled a vast distance, billions of light years, to reach Earth. That pointed towards something truly extraordinary happening out there in the cosmos.
So one bizarre signal could be dismissed as a fluke, but then what happened?
Yeah.
How did we go from one odd blip to confirming that FRBs are a real phenomenon?
Well, as the years went by, more of these bursts were detected by different telescopes around the world.
Okay.
Each one had similar characteristics.
Okay.
Incredibly brief, incredibly energetic,
Mm.
and originating far beyond our galaxy.
Wow.
That's when the astronomy community really took notice.
Yeah.
It became clear that this wasn't just a random occurrence,
Right.
but a new class of astrophysical events demanding an explanation.
But it's almost like the universe was sending us a message.
Yeah.
We were just starting to pick up on the signal.
That's a great analogy.
Now, our source material mentions the sheer power of these FRBs.
Oh, yeah.
It says some release as much energy in a fraction of a second as the sun does in thousands of years.
Thousands.
How do we even begin to comprehend that kind of energy?
It's truly mind-boggling, isn't it?
It is. It's like every single power outlet on Earth running at full blast for millennia,
Wow.
all packed into a tiny burst of energy.
Wow.
It speaks to some incredibly powerful processes happening out there in the universe.
You said these signals originate from outside our galaxy.
Yes.
How can we be so sure about that?
Yeah.
I mean, space is vast and full of objects.
It is.
How do we trace these bursts back to their source
Right.
and determine their distance?
That's a great question.
Yeah.
It all comes down to a phenomenon called dispersion.
Okay.
As these radio waves travel through space, they interact with the interstellar medium,
Okay.
the gas and dust that exists between stars and galaxies.
Mm-hmm.
This interaction causes different frequencies of the radio waves to travel at slightly different speeds.
So the signal gets kind of stretched out as it travels.
Exactly.
Uh-huh.
And the more stretched out the signal is when it reaches us,
Yeah.
the more matter it has passed through,
Mhm.
which means the farther it must have traveled.
It's like looking at a distant light through fog.
Right.
The thicker the fog, the dimmer and more diffused the light appears.
Yeah.
By analyzing this dispersion measure of an FRB,
Okay.
astronomers can estimate how far the signal has traveled
Uh-huh.
and confirm that it originated far beyond our own galaxy.
So, in a way, these FRBs are acting like probes,
Yeah.
illuminating the vast spaces between galaxies and revealing information about the distribution of matter in the universe.
You got it.
Wow.
They're like cosmic X-rays,
Oh.
giving us a glimpse into the structure and composition of the universe in a way that was never possible before.
Okay.
For example, by studying how FRB signals are bent by gravity as they pass through galaxy clusters,
Okay.
we're getting a clearer picture of how dark matter,
Right.
which we can't see directly, is
Mhm.
distributed.
Wow.
That's crucial to understanding how galaxies form and evolve.
So we have these intensely powerful bursts
Yes.
originating billions of light years away,
Right.
acting as probes of the cosmos.
It's incredible.
And there's another layer to this puzzle, right?
Yeah.
Not all FRBs are the same.
Exactly.
Some burst once and disappear, while others repeat their signals.
Yes.
Tell me more about that.
You're right. Not all FRBs behave the same way.
Okay.
Some, like the first one we discovered, FRB 010724,
Yeah.
appear just once and vanish.
Okay.
But then we have others,
Okay.
like FRB 121102,
Uh-huh.
that have been observed to emit multiple bursts,
Wow.
sometimes in irregular patterns.
Okay.
It's this repeating nature that deepens the mystery surrounding FRBs
Right.
and raises even more questions about their origins.
Yeah. The repeating FRBs sound particularly intriguing.
Yeah.
Does this difference in behavior,
Yeah.
the one-offs versus the repeaters,
Mhm.
suggest multiple types of FRBs with potentially different origins?
Right.
Or could the same phenomenon explain both?
That's the million-dollar question.
What is?
It's certainly possible that different mechanisms are at play. Perhaps the one-off bursts are generated by cataclysmic events, while the repeaters are driven by some ongoing process.
Okay.
Or maybe it's the same type of source.
Right.
But something about the environment or the orientation of that source
Yeah.
determines whether we observe a single burst or multiple signals.
Right.
It's a puzzle that scientists are actively trying to solve.
It's like we have two separate cosmic crime scenes,
Yeah.
but maybe the same perpetrator is responsible for both.
Exactly.
Well, this is getting really interesting. Now
Okay.
that we've got a handle on what FRBs are
Yeah.
and the puzzle they present,
Mm.
I'm dying to dig into the possible explanations.
Me too. Let's dive into those next.
Mm.
So let's talk about the potential culprits behind these powerful signals.
Okay.
One of the leading contenders in the FRB mystery
Yeah.
is a fascinating object called a magnetar.
Magnetars, right.
Yes.
I've heard of them,
Yeah,
but they're still kind of a mind bender for me.
they are.
They're like neutron stars, but even
Yeah.
more extreme, right?
Exactly.
Okay.
Picture this.
Okay.
A neutron star is already an incredibly dense object,
Yeah.
the collapsed core of a massive star,
Okay.
squeezed into a sphere only a few miles across.
Right.
Now, amp up the magnetic field
Okay.
to trillions of times stronger than Earth's magnetic field.
Trillions.
And you've got yourself a magnetar.
Wow. Trillions of times stronger.
Yeah.
So how does this insane magnetic field play into generating something like an FRB?
Well, these ultra-strong magnetic fields are inherently unstable.
Okay.
Imagine it like a tightly wound spring,
Okay.
constantly under immense pressure.
Hmm.
When these fields shift or realign,
Yeah.
it's like that spring suddenly releasing,
Yeah.
unleashing an incredible amount of energy.
Right.
This energy can then be converted into radio waves
Okay.
through a complex process involving the acceleration of particles to nearly the speed of light.
So it's like a cosmic earthquake.
Yeah.
But instead of rock, it's
Uh-huh.
this unimaginably powerful magnetic field.
Exactly.
Suddenly snapping and
Yes.
unleashing a torrent of energy. And
Uh-huh.
that's what we detect as an FRB.
That's the leading idea.
Okay.
And there's actually some pretty strong evidence linking magnetars to at least some FRBs.
Really?
In 2020,
Yeah.
astronomers observed an FRB coming from a known magnetar in our own galaxy.
Wow.
That was a huge breakthrough,
Yeah.
providing the first direct observational evidence linking FRBs to these extreme objects.
That's a pretty compelling piece of evidence.
It is.
But if magnetars are the source of FRBs,
Yeah.
how do we explain the ones that repeat?
Right.
Could a single magnetar produce multiple bursts like that?
That's a great question.
Yeah.
And it's one of the key challenges for the magnetar model.
Okay.
While it's possible for magnetars to experience multiple magnetic field realignment
Oh, yeah.
or starquakes over time,
Okay.
it's unclear if those events could generate FRBs with the kind of repeating patterns we observe.
Right.
Some scientists think it's plausible,
Yeah.
others aren't so sure.
Okay, so maybe magnetars are responsible for some FRBs, particularly the one-offs,
Yeah.
but not all of them.
Right.
What other celestial events could possibly generate these incredibly powerful signals?
Well, let's ramp up the energy scale even further.
Okay.
Another possibility
Yeah.
involves the collision of two incredibly dense objects,
Okay.
neutron stars.
Two neutron stars smashing together.
Yeah.
That sounds cataclysmic.
It absolutely is.
Wow.
When two neutron stars collide,
Yeah.
it's one of the most violent events in the universe.
Okay.
They merge into a larger object,
Mm-hmm.
And the energy released in this process is staggering.
Wow.
It creates a kilonova,
Okay.
a massive explosion that generates gravitational waves, gamma rays,
Wow.
and potentially fast radio bursts.
So are we thinking that kilonovas
Yeah.
might be the source of those one-off FRBs?
That's one possibility.
Okay.
The sheer power of a neutron-star collision could certainly explain the energy levels we see in FRBs.
Right.
And since these collisions are relatively rare events in the universe,
Yeah.
they would naturally produce bursts that only appear once.
Okay.
However,
Yeah.
it's not clear if the specific mechanisms involved in a kilonova
Okay.
would result in the distinct characteristics of FRB signals.
Right.
More research is needed to confirm or rule out this possibility.
It makes sense that a single
Yeah.
incredibly energetic event like a kilonova
Right.
would be a good candidate for the one-off FRBs.
Yes.
But when we talk about repeaters,
Yeah.
those colliding neutron stars would need to, well, collide repeatedly, right?
Exactly.
And that seems pretty unlikely.
You're exactly right.
Yeah.
That's a major hurdle for the kilonova hypothesis when it comes to explaining repeating FRBs.
Okay.
It's unlikely that we'd have multiple neutron star collisions happening repeatedly in the same location.
Okay, so we've got magnetars,
Mm-hmm.
possibly explaining some FRBs.
Yeah.
And neutron star collisions,
Right.
maybe explaining the one-offs. But are there any other contenders in our cosmic lineup of suspects?
Well, we can't have a conversation about energetic cosmic events
Right.
without bringing up the ultimate heavyweight
Okay,
black hole.
black holes.
Yes.
Those enigmas of the universe
Yeah.
with their immense gravitational pull
Mm-hmm.
and the ability to warp space and time.
Right.
What role could they possibly play in the FRB puzzle?
One intriguing scenario
Okay.
involves a process called tidal disruption.
Okay.
Imagine a star getting too close to a supermassive black hole.
Okay.
The black hole's immense gravity starts to stretch and tear the star apart,
Right.
a process we call spaghettification.
Spaghettification.
Yes.
Okay, that's a new one for me.
Yeah.
But I think I get the idea.
It's a pretty vivid analogy.
Yeah.
As the star gets stretched and torn apart,
Right.
it releases an enormous amount of energy,
Okay.
potentially in the form of radio waves, which we could observe as an FRB.
Right. So would this be a one-time burst, like the kilonova scenario?
It depends.
Or could a black hole create repeating FRBs?
That depends on the specifics of the interaction between the star and the black hole.
Okay.
A single tidal disruption event could certainly produce a one-off FRB.
Right.
But if we have a scenario where a black hole is continuously pulling in material
Yeah.
from a nearby star or a surrounding disk of gas and dust,
Okay.
that could potentially generate repeated bursts over time.
So black holes, with their immense power and their
Yeah.
potential to interact with matter in various ways,
Yes.
could be a viable explanation for both one-off and repeating FRBs.
And it's worth noting that we're still learning so much about black holes and their behavior.
Right.
There could be processes and interactions that we haven't even considered yet
Yeah.
that could be generating these enigmatic signals.
Black holes are always a wild card in these kinds of cosmic discussions.
They are.
Okay, so we've got magnetars, neutron star collisions, black holes.
Mm.
Is there anyone else we should be considering in our FRB lineup?
Well, there's one more possibility we should mention,
Okay.
though it's far more speculative
Okay.
and lies on the fringes of mainstream scientific thought.
Okay, I'm intrigued. Lay it on me.
Some scientists have proposed that FRBs could be signs of advanced alien technology.
Oh, hold on.
I know.
Are we talking about aliens sending us signals?
Well,
Like intentional signals?
some people think so.
This is getting into science fiction territory.
I know, it sounds far-fetched, right?
Yeah.
And it's important to emphasize that there's currently no direct evidence to support this idea.
Okay.
But the thought is that a sufficiently advanced civilization might be able to generate incredibly powerful, focused bursts of radio waves,
Right.
perhaps as a form of communication, a beacon to announce their presence,
Yeah.
or even as part of some technology we can't even comprehend.
That's definitely a mind-blowing possibility.
It is.
Imagine if those repeating FRBs were actually coded messages from another world.
That would be incredible.
It would be the biggest discovery in human history.
It would indeed.
But as exciting as that possibility is,
Yeah,
it's crucial to approach it with a healthy dose of skepticism.
absolutely.
We need extraordinary evidence to support such an extraordinary claim.
Right.
Until then,
Yeah.
it's important to focus on exploring the natural astrophysical phenomena that we know can produce these kinds of energetic events.
You're right.
That makes sense.
Yeah.
It's important to keep our feet on the ground, even when we're discussing events that seem straight out of science fiction.
Exactly.
So we've got a lineup of suspects,
Yeah.
each with its strengths and weaknesses.
Right.
But beyond just trying to pinpoint the cause of FRBs,
Yeah.
scientists are also looking at what these signals can tell us about the universe itself, right?
Absolutely.
Okay, so let's shift gears a bit
Sounds good.
and delve into the realm of FRBs as cosmic tools.
Okay.
I remember you mentioned earlier how the way FRB signals get distorted as they travel through space
Yeah.
can reveal information about the distribution of matter in the universe.
So like acting as cosmic X-rays.
Right.
Tell me more about that.
Remember that dispersion measure we talked about? How
No.
the signal gets stretched out depending on how much interstellar matter it's passed through?
Hmm.
Well, that's not the only way FRBs can reveal information about the universe.
Okay.
As these signals travel billions of light years to reach us,
Right.
they also interact with the large-scale structure of the universe,
What?
passing through galaxy clusters,
Mhm.
filaments of gas,
Right.
and even the vast voids between galaxies.
So it's like these FRBs are giving us a three-dimensional map of the universe.
Exactly.
Wow.
By studying how the signals are bent and distorted by gravity as they pass through these structures,
Yeah.
we can get a much clearer picture of how matter is distributed throughout the universe,
Wow.
which is essential for understanding how galaxies formed and evolved over cosmic time.
Wow. That's amazing.
It is.
It's like using these bursts of energy from billions of years ago
Yeah,
to create a cosmic map.
it really is. And there's another fascinating aspect of FRBs as cosmic probes that we haven't touched upon yet.
Okay.
Remember dark energy?
Yes.
That mysterious force that's causing the expansion of the universe to accelerate?
Exactly.
Oh, yeah, dark energy.
Yeah.
The big enigma in cosmology.
It is.
It's the stuff that makes up something like 70% of the universe.
Right.
But we have no idea what it is.
Precisely.
And FRBs could actually hold the key to unlocking the secrets of dark energy.
Some people think so.
Okay, I'm all ears.
All right.
How could these bursts of radio waves
Yeah.
possibly help us understand something as elusive as dark energy?
Well, as these FRB signals travel across the vastness of space, the expansion of the universe causes their wavelength to stretch,
Okay.
a phenomenon known as redshift.
Right.
The farther the signal has traveled, the more its wavelength is stretched.
Right, that makes sense. The
Yeah.
expansion of the universe stretches out everything.
Exactly.
Including light and radio waves. And by carefully measuring the redshift of FRBs, especially those coming from very distant sources,
Right.
astronomers can gain insights into the expansion history of the universe.
Exactly.
Okay, so how does that connect to dark energy?
Well, the rate of expansion of the universe is directly influenced by the properties of dark energy.
Okay.
If we can precisely measure how the expansion rate has changed over cosmic time,
Right.
we can constrain the nature of dark energy
Yeah.
and get closer to understanding what it is and how it works.
So FRBs are acting like cosmic stopwatches,
Yeah.
giving us a way to measure the universe's expansion rate across billions of years.
That's a great way to put it.
And potentially unlock the secrets of dark energy.
They're like time capsules,
Wow.
carrying information about the evolution of the cosmos,
It's incredible.
encoded in their stretched out wavelengths.
We've gone from these enigmatic bursts
Yeah.
to realizing they're like powerful tools for understanding
Right.
the fundamental structure and evolution of the universe.
I know.
But what's next for FRB research? Are
Yeah.
scientists just going to sit back and wait for more of these bursts to happen by chance?
Not at all.
Okay.
The field of FRB research is incredibly dynamic
Yeah.
and rapidly evolving.
Right.
There are exciting new instruments and technologies coming online
Okay.
that are poised to revolutionize our understanding of FRBs.
Yeah. This sounds exciting.
It is.
Tell me more about these cutting-edge tools and what they'll allow us to do.
One of the most game-changing developments in the field
Yeah.
is the Square Kilometer Array, or SKA,
Okay.
currently under construction in Australia and South Africa.
I've heard whispers about this SKA.
Yes,
It's going to be the biggest radio telescope ever built, right?
you're right.
Wow.
It's going to be absolutely massive.
Okay.
The SKA will be comprised of thousands of antennas
Wow.
spread across vast distances,
Okay.
working together to create an incredibly sensitive and powerful radio telescope.
So what impact will the SKA have on FRB research?
Oh, it's going to be revolutionary.
It sounds like it's going to be a game changer.
With its unprecedented sensitivity,
Yeah.
it'll be able to detect thousands more FRBs,
Wow.
including much fainter ones that current telescopes might miss.
Okay.
And that means more data to analyze, more clues to unravel the mysteries of FRBs.
More FRBs, more data, more clues.
Yeah.
This sounds promising.
It is.
What else will the SKA allow us to do that we can't do with current telescopes?
Imagine this.
Okay.
The SKA's incredible resolution.
Yeah.
We'll be able to pinpoint the locations of FRBs with much greater precision than ever before.
Wow.
We might even be able to trace them back to their host galaxies,
Really?
allowing us to study the environments where these bursts originate.
Wow, that's incredible.
Yeah.
Being able to pinpoint the location of an FRB
Yeah.
and identify its host galaxy would be like getting a return address on a cosmic letter.
Exactly.
It would allow us to study the specific conditions that might be giving rise to these bursts.
Yeah, God.
We might finally be able to answer the question of whether different types of galaxies are more prone to producing FRBs,
Right.
whether there's something special about the stellar populations in those galaxies, or whether the presence of black holes plays a role.
It'll be
The
fascinating.
SKA sounds like it will finally give us the tools to really crack the FRB code.
It might.
It's incredible to think about the breakthroughs that might be just around the corner.
I know.
Are there any other technological advancements that are going to play a role in the future of FRB research?
There's another exciting development that's going to be crucial in this field.
Okay.
It involves something we've all been hearing a lot about lately.
Okay.
Artificial intelligence.
AI.
Yeah.
How is artificial intelligence going to help us understand these bursts of energy from billions of light years away?
Think about the sheer amount of data
Okay.
that telescopes like the SKA are going to generate.
Yeah.
It's going to be an astronomical amount of information.
It will.
Far too much for humans to sift through manually.
Right.
That's where AI comes in.
So AI is going to be our new research assistant,
Exactly.
helping us make sense of all that data.
AI algorithms are incredibly powerful at pattern recognition and anomaly detection.
Right.
They can be trained to sift through vast amounts of data,
Okay.
identify potential FRB signals that might be missed by human eyes, and even help us classify different types of bursts based on their characteristics.
It sounds like a perfect partnership. Powerful telescopes like the SKA, gathering vast amounts of data, and AI algorithms helping us make sense of it all.
You've got it.
And this collaboration between cutting-edge technology and human ingenuity is what's going to propel the field of FRB research forward in the coming years.
I agree.
We're on the cusp of a new era of discovery where we might finally be able to unravel the mysteries of these enigmatic signals and the secrets they hold about the universe.
That could be amazing.
FRBs have really come a long way.
They went a weird blip to, like, wow, a whole new field of astronomy.
Absolutely.
It's amazing to think that a decade ago,
Yeah.
FRBs were considered an anomaly.
Right.
Just a blip in the data.
A fluke.
And now they're opening up entirely new avenues for understanding the universe.
Yeah, they're helping us probe the nature of dark energy, map the distribution of matter, and challenge our understanding of extreme physics.
It's like we stumbled upon a cosmic Rosetta Stone.
That's a great analogy.
And we're just beginning to decipher its language.
Yeah.
Speaking of deciphering, we've explored a fascinating array of potential sources for these FRBs, magnetars, neutron star collisions, black holes, and even the possibility of advanced alien technology.
That's right.
What stands out to you as the most likely explanation?
Well, it's still too early to definitively say. Each theory has its strengths and weaknesses, and we need more data to really narrow it down.
Okay.
The magnetar connection is compelling.
Especially with that 2020 observation of an FRB coming from a magnetar in our own galaxy.
Right.
But it's not a perfect fit for all FRBs.
Yeah.
Especially the repeaters.
So the repeaters are a real head-scratcher.
They are.
They seem to suggest something more dynamic and ongoing
than
a single cataclysmic event.
Right.
Neutron star collisions.
Yeah.
They're still a strong contender for the one-off FRBs.
They are.
But they don't quite explain repeaters.
Right.
And then there's the black hole scenario,
Yes.
which opens up even more possibilities.
It does.
Tidal disruptions, accretion disks,
Yeah.
maybe even processes we haven't even imagined yet. But black holes are such extreme environments.
Right.
We're only just scratching the surface of understanding their full potential.
We are.
And of course, there's the ever-tantalizing possibility of alien technology,
Of course.
which would be, well, the most mind-blowing discovery in human history.
The biggest ever.
But as we discussed, extraordinary claims require extraordinary evidence.
That's right.
And we're not there yet.
Not yet.
For now,
Yeah.
the most likely explanations lie in the realm of natural astrophysical phenomena.
Right.
It's important to keep an open mind,
Absolutely.
but also to ground our investigations in scientific rigor.
Yes.
The beauty of science
Yeah.
is that it's a process of continuous discovery and refinement.
It is.
We might find that the answer to the FRB puzzle lies in a combination of factors.
Right.
Or perhaps something entirely new will emerge that we haven't even considered.
It's possible.
That's what makes this field so exciting.
It is.
It's a constant exploration of the unknown.
Yeah.
Pushing the boundaries of our understanding.
Absolutely.
And it highlights how much we still have to learn about the universe.
It really does.
For all our scientific advancements,
Yeah.
we're still just scratching the surface of what's out there.
I agree.
So, as we wrap up our deep dive into the world of fast radio bursts,
Okay.
we'll leave you with this. What do you think is causing these incredible bursts of energy?
What do you think?
What new discoveries await us as we continue to explore this cosmic mystery?
Yeah, it's exciting.
The universe is full of wonders.
It is.
And with each new discovery, we get a little closer to understanding our place within its grand tapestry.
Absolutely.
Thanks for joining us.